When you get into finishing, like people say, I don't know, it's a black art. It depends on my coating. It depends on the humidity. It depends on my catalyst. It depends on my mill thickness. It depends on all these things that people sometimes feel like they're out of control of it. It's like, well, whatever happens, happens. We just got to get it finished. And we say like, that's probably one of the most important parts of your process. It's what everyone touches and sees and feels. And we've seen that it's just a battle for so many shops. Like getting finishing right is such a battle.
Welcome to Verify in Field, the millwork podcast. Here's Jacob.
Welcome back, everybody, to Verify in Field. Today I have Ryan Randell, who is the National Director at Elevated Finishing with us. And we're going to talk about some of the new products they have, the Shoebox being one of them. And thank you for joining us today, Ryan.
Yeah, no problem, Jacob. Thanks for having me on, man.
So, I think to get started, would you mind just giving a little bit of background on how you got into the finishing industry and the millwork industry?
Sure. Yeah, it's been a long, circuitous route to get here. I didn't start in this field till about 12, 13 years ago now. I was working actually at a tobacco facility here in Winston, and I wanted to do something different. So I got into computer programming, actually. It's weird enough. And if you ever heard of those boot camps where you can go 6 months, learn how to code, get a job, all that stuff, you heard of those?
Yeah.
Yeah. So I did one of those and it worked out fine. Made it through, got a job. Crazy thing is, I don't know, 3 months later, the whole company shut down. So I was then instantly without a job. And so I was just looking for something to do. Honestly, had a young family, needed to get just busy. And I've always worked with my hands. My dad was a contractor, remodeling, exterior work. I just always been busy in that and saw a job with a company called Styles Machinery, who I know you're familiar with, as an application engineer. And so I said, hey, I'll learn something new. And so I went in there and worked in the finishing lab, in the sanding lab, ran demonstrations. And that's really where I got my feet wet and paid my dues in the finishing world and learned a lot about reciprocators, learned a lot about sanders, learned a lot about coatings, just learned a lot about the industry, period, and had a lot of great mentors along the way while I was there. And that's kind of where I started. That's where I learned about the industry and the work finishing.
Awesome. So from there, did you go straight from Styles to Elevated Finishing?
No. So what we did, I worked for Styles for quite a while and had an opportunity with a paint company, actually, Renner Coatings, and started with them. I worked for them about a year and it was fine. It was a good job. Learned a ton about coatings, but just wasn't really what fit me very well. And so Lance and Kobe Johnson with Advanced Machinery, who was a Styles dealer, and I had known them for years. We did demonstrations. I went out there when I was selling paint and traveled around, and they began importing Shoebox, I don't know, 4 or 5 years ago, and were wildly successful with it. And so one day when I was out there with them, Lance actually said, hey, have an idea. And so we talked about it for a few months, kind of what it would look like to bring the shoe boxes to the rest of the U.S. market. And this is where we ended up. Elevated Finishing put together this company. And so now we're the U.S. importer to the U.S. of shoe boxes. So that's kind of long story short, it's where we started.
Awesome. So I guess that's a good segue. You mentioned the Shoebox. And so this is a product that you guys are the importers and sell and implement these things. I saw that's how we met at IWF. You guys had the Shoebox there. And so it is a relatively new product in the U.S. market, as you mentioned, but it's been in Europe for a while, I assume?
Yeah. So the Shoebox, the technology itself, catalytic IR, has been around 15, 20 years. It's not a brand new technology. It's iterated to get better and better, but it's not a brand new technology. Schubert's is a UK based company, and it's like their 4th generation now that they're on it. And it's been very successful over there for years. They went to Canada first and then hesitant to get into the US market at first, just because if you fall on your face when you get into the US market, it's hard to get back in and you can't really be successful. So they were slow to get in there, but the way they got in was Kobe Johnson, Advanced Machinery, just saw this hole in what he could offer when it comes to finish shops and how curing was a really big problem. But there's this range of, you can either buy a full line or you can buy a big room that's hard and requires a lot of energy and requires a lot of space. And you just wanted something in the middle. You had a lot of like small to mid-sized cabinet shops that aren't going to invest in a full system, or maybe even a reciprocator, but they need curing. And so he just called them, said, hey, let's figure this out. And they figured it out. And so we got these moving, and we got, I don't know, over 100 of them now in the US. And so it's been about 4 years since it's been in the US market, but it's not a new technology.
Okay. So yeah, could you tell me a little bit more? So you explain this feels like kind of this middle ground, right? Where some shops before this would invest in a full line, which meaning it sounds like a full automated finishing line, right? Where you have everything from actually applying the finishes, the sanding, applying the finishes, and the curing right into an automated line. And then the other end of the spectrum would be everything is kind of manual, right? You still have paint spray booths, and then you either are taking time for it to cure or you have an oven or something, right? And can you talk about the differences of those extremes and then how this fits in the middle of that?
Yeah. So when you see most shops, I would say 80% of them, not 80, maybe 70, still are just a booth, spray guns, racks. They spray it, they rag it, they wait, and they're done. There's a large number of shops in the US that are finishing that way. The rest of them will get into some automation, like they'll get a flat line or they'll get maybe some kind of curing, but not usually. Usually curing is on the back end of that. And so when they're looking at like, hey, how do I automate? How do I get better? How do I do these things? A really simple place to start that we found is just, hey, can you cure your parts faster? Because universally, if you don't have curing, you have a bottleneck. It's just period. It's how it is. It takes a long time for coatings to cure. And so there's just a bottleneck that they run into. And so shops, when they want to get into a full line, you really have to have space. Like you have to have space. A lot of them are 70 foot to 100 foot to, 70 foot wide. It just depends on the volume, because you can get into just a simple reciprocator, flash oven, infrared, or hot air oven, and then done. Or you can get into a full system that's U-shaped. You have full line control where you can load a part on the end. It's going to go around the circle. It's going to flip automatically. It's going to spray again. Automatic color changes. You can almost fully automate, but there is a cost and there is a utility requirement and there is a space requirement that most shops just aren't there. Most woodworking shops aren't giant manufacturing facilities. A lot of them are mom and pop shops. A lot of them are just small 7 to 15 man shops that are just trying to figure it out. They don't have that kind of footprint to work with. And so where we come in is we come in like, hey, we can give you automation. We can create space immediately with this shoebox to give you some throughput just right away. It's a very easy implementation. It's not a whole shift in your production, we'll say, because when you go to flatline, you have to then shift, okay, only flat parts get finished in here. So we'll have some here, we'll have some here. We got to figure out where to marry them at the end. Yeah. And so there's just more things to figure out. With what we do, the implementation is very direct, very simple.
Because even if shops that do have a flat line, like you mentioned, there are limitations, right? Because it's only flat parts. So you're either, if you're doing cabinets or even custom assemblies, it's okay, can you pre-finish them before assembly and then assemble? But inevitably, every shop still encounters products that can't go through a flat line.
You
get the same finish. So that's where you still are doing the spray booth and you still are either waiting, most of them waiting for a finish, or you're trying to speed it and wrapping things and trying to protect the finish without damaging it to get it to the job site. And that's the bottleneck you described, because almost every shop you're working like you are with non-finished goods, right? If you're doing laminate or other stuff that you can get it fully assembled, you don't have this issue. But then you maybe on the same job have stained cabinets or stained assemblies that have to go through finish, and you're sitting there trying to wait for them to cure. And also, depending on where you are in the country or what the weather is, that can wildly vary your curing times and also what products you're able to work with, I would imagine.
Yeah.
Right?
Yeah. All of those are variables. They're all big things. So shop environment is a big piece of that. Like how dirty is it? Right. We get a lot of contamination things if you're in a small shop and you're sanding here, you're finishing here, but you're only finishing a little bit. And then you have to take that rack and move it to a different spot. So then it's just kind of hanging out. So you definitely need a space to keep it safe and cured. But like you were mentioning, flat lines do not do everything. We have these right beside fully enclosed flat lines, because there's sometimes people just don't want to load up a flat line to run 6 parts, right? You don't want to load up a flat line to run one-off colors. You want to just do that in your booth, get it done, get it out. Or your rework, right? You're running like all these parts of the flat line, but something got damaged on site. You got to turn some parts over quickly. or samples. There's all these little ways that when you don't have curing, at least the kind of flexible curing that a room would offer, you just run into a wall. You just got to wait over and over. And it's a big headache. And all the shops we're in, like, curing is almost always one of their biggest headaches, because finishing, like what you guys do, is very, like when you're talking about drawings and CAD, it's very direct. Like, I know exactly what this measurement's going to be. I know what it's going to look like. I can tell you exactly how long it's going to take to run through my CNC, tell you exactly how long it's going to run through my edge bender. Like, those are very known commodities. When you get into finishing, like, people, I don't know, it's a black art. It depends on my coating. It depends on the humidity. It depends on my catalyst. It depends on my mill thickness. It depends on all these things that people sometimes feel like they're out of control of it. It's like, well, whatever happens, happens. We just got to get it finished. And we say, like, that's probably one of the most important parts of your process. It's what everyone touches and sees and feels. And we've seen that it's just a battle for so many shops. Like, getting finishing right is such a battle.
Yeah. Therein comes the Shoebox, this product that you've talked about, and it's technology that's been around for a while. But can you give us a little bit more detailed explanation of what is the Shoebox? How does it work?
Yeah. So the Shoebox, our primary method of curing is long wave infrared. It's a gas catalytic panel that uses, for use a scientific word, it's an exothermic chemical reaction. It means we interact gas with a platinum catalyst. And so when you have a hot platinum, it'll interact with gas and create that long wave infrared that we need and that heat. And so when we mix, whether it's natural gas or propane, when we mix it and we pass it across the face of this emitter, we're getting long wave infrared and a little bit of heat. The reason we like long wave infrared is because it has a long travel distance, right? You have long wave that's going to move, it's going to be able to reflect. That's a big piece of our technology, is the ability to reflect our infrared. And it doesn't get as hot as the others, right? The intensity, the energy intensity comes back a little bit. So when you're working with coatings, you don't want to shock the coating. You don't want to like put too much heat too fast. You don't want to get it too hot, because you are working with wood substrates or plastic or heat sensitive substrates. And so if you start baking them and cooking them too quickly or for too long, you're going to really mess up your substrate, whether it's the wood or MDF or plastic or glass or whatever we're working with. And so we like the long wave infrared because, one, it's low energy, but two, because it reflects, and then three, because it can penetrate coatings. And so the way that works is that infrared, because it's just a light wave, right? Infrared is a light wave, and it reflects across all the parts of this room and it penetrates coatings. And so when we're penetrating those coatings, we're driving our carrier liquids out, whether it's a solvent, whether it's a urethane, whether it's a water-based coating. We're getting to the bottom, we're going to the substrate and pulling up. And so that kind of flips on its head what traditional curing is. Most of the time it's air dry, right? You pull it out, you air dry, and it's a top-down cure, meaning you're going to form a film and it's just going to work its way down until it gets to the bottom, which is, a very, very common way most people do it. And how traditionally shops have done it, even if they're building a room, they're putting warm or hot air in there, but it's still a top-down cure. And so as that film gets dry, it gets thicker, and then the underneath has a harder time coming out, right? So it slows down dramatically. The first, 15, 20, 30 minutes of cure goes really fast, right? You can get almost to attack free relatively quick. But the problem is you have another 12 to 24 hours for it to be actually cured and actually usable and actually be able to flip the part or package the part or stack it. So you have this huge wait time to get it cured. And that's because there's still solvent or water trapped underneath that film. You got to just let it finish. And so what we do is we start at the bottom and cure up. And so when that substrate or when that coating is dry at the top, everything below it's dry as well. And we can do that with the long wave because of the way that light wave penetrates that coating. And so that gives us, just incredibly short cure times, but also a fully cured time instead of just, hey, it's kind of dry to the touch. I don't know if I can flip it. I don't know if I can package it. I don't know if I can just move it on or to assembly or whatever. And so that's what we do. We control the air in the room. Everything's filtered. We move the air around because that's what you need to cure, right? You need some heat. We like some infrared and we like air movement, especially for your water-based coatings, because as that water vapor comes up, we want to get it off the face of that. And so we have our own air control, right? So we have the ability to move our air. We recirculate some of it. We exhaust some of it, depending on the coating, depending on what they're running and how they're running it. So it's a lot of flexibility with it. The other thing, I'm kind of rambling, but I got a lot of stuff on this, is our ability to put parts anywhere you want. Since it's not a directional cure, it's a reflected cure. I don't have to put my parts in front of that panel. I can just put parts front to back, left to right, fill the whole room up, and they're all going to cure. And that's a really unique application. It's a unique way to cure. There's really nobody that cures that way. And it's something that we get to do just because of the way we use long wave, the reflective stainless steel, and the air movement.
Yeah. So this is a self-contained product, right? This is comparable to what people might envision with either an oven or a paint booth, right? That you can stand this up in a space, and that is very largely different to other comparable ovens, I would think, as far as what you need space-wise as well as utility hookup, I think, right?
Yep. Yeah, it is 100% standalone. We have our own service crew. We have our own parts department. We control the whole process front to back. And so our guys come in, it is a standalone unit. We put it wherever you want to. And it's fully customizable. We have some that are L-shaped, go around corners. We have some that are tall, some that are wider, some that go through walls because, hey, I want part of it in my finish room, I want the other part of it in my assembly area, or when I'm done, I can just take it out of my room just to save space. And so it is unique because we can make it however we want to. And it does stand alone, and our utilities are hooked up to it. We use natural gas or propane and some power. But the primary driver is gas catalytic, is where we get our infrared from. The power is to keep the fan moving and control cabinet.
And what about exhaust or things like that?
No, we do not have to exhaust it. Some choose to. It depends on the local code of what they want. But one of the reasons we don't have to actually punch a hole in your shop is because it's not technically an oven. It does not get the right amount of temperature. It doesn't get hot enough. We don't use enough gas. Our infrared is completely flame free. There's zero combustion whatsoever. It's 100% chemical reaction. So there's zero opportunity for a flame, and there's zero opportunity for any other kind of byproducts. With combustion ovens, like when you have combustion, you get byproducts. You get harmful vapors that happen when combustion happens. That's why we have catalytic converters on your car. That's why we have exhausts on these propane burners, is because there's harmful chemicals that are a result of that process. Because we use straight chemical reaction, we don't have any harmful byproducts. So all we're doing really is capturing what's already in your shop, off-gassing. And if it's a solvent, we're actually mitigating VOCs. If it's a water, we're creating a humid-free space and getting the water vapor out. And I want to touch on that a little bit, is because the way that VOCs work when you're using a conversion or a solvent-based paint, that's actually harmful off-gassing. It's called a VOC, a volatile organic compound, and it's not great for you, right? And most places charge you per ton of however many VOCs you are emitting or shooting out of your shop, like when you're spraying or things like that. What we can do, because it's just a chemical reaction and we can use gas for it, we actually can take the vapor that's coming off your parts, and as we recirculate it, we bring it back across the face of that gas emitter and we oxidize. So we change the chemical nature of that gas to carbon dioxide and a little bit of water vapor. So we actually mitigate VOCs in the shop. It becomes, the smell drops considerably and the actual amount of VOC in your shop changes. And so that's why we don't have to exhaust it, because if you're just air drying your parts anyway, it's all sitting in your shop. All we're doing is taking what's in your shop and we're mitigating the VOC, or we're just controlling the air. So
what type of maintenance does one of these have? Like, are you having to change out platinums or anything like that?
So platinum is what they call a noble metal, which means it doesn't degrade with use. So when you heat it up and we use it as a catalyst, it doesn't wear out. Like, there isn't a life on it that then wears out. What will kill it is dust. When there's a lot of dust in that room, what will happen is it'll start to accumulate on the face of that emitter and then burn itself to the fiber in there. And then the reaction's still happening, but there's a wall of dust. And so you don't get your actual long wave IR out of the face of that emitter. And so the maintenance is keep dust off the walls. And so you can see it when there's dust on the walls, you can kind of see as it's accumulating. Time to clean our room. And so it's just simple as brushing the walls down, vacuuming it up off the floor. Those emitters, you're just going to use a brush, soft brush, and knock the dust off of it. and go from there. We do have a filter, so we control all the air coming in, but that's it. This is taking care of those emitters, because that's the life of that machine, is that emitter curing your parts.
So for most shops, are you seeing, that this takes like one of your typical clients that has a paint booth, has spray booth, they're using maybe different catalysts depending on the year, different formulations, but depending on the weather and the time of year.
Sure.
But largely they're air drying, right? Or they're just waiting. And so this speeds up right away that cure time. Yeah. But how else does it change their workflows usually?
Well, finishing becomes predictable, right? One of the things that you'll see in shops without automated curing or without any kind of curing at all is the actual throughput is unpredictable. We get it to the shop, it gets into finishing, and it just gets stuck for a while. There's no real, like, hey, I know it'll take this long, this group of days to get it out. So, hey, it's going to be in finishing for a while. Depends on how quick stuff gets cured, depends on how quickly we can process stuff. And so one of the things it does is it really opens up scheduling. It lets you actually understand and know and cost correctly, like how much time, labor, and energy are being put into your finishing, as opposed to air dry. When you're waiting for those parts to dry, you're just guessing. Honestly, you're guessing, or you make your dry time so big that you can't screw it up, because if you go too quick, you flip parts too quick, or you try to sand too quick, and you just screwed up your part, and then you got to redo the whole thing. You got to strip it back down and do it again. That's a huge cost and a huge time burden. So it makes it predictable. Obviously, the reduction, when you're talking about a conversion bar and a shrink time, anywhere from 8 hours, 12 hours, 24 hours to cure, right? And so most shops, what I see is when they don't have curing, they're going to do their primers, because primers cure quick, sealers cure quick. They're high solids and they cure quickly. But when you get to your top coats, where the time just takes forever, there's 3-4 days sometimes to get through, a job, to get it sprayed and sanded and cured out the door. And so what we can do is we take what would take 8 hours on the low end to be ready to flip or ready to be packaged. Most shops wait overnight just because it's safe. They want to screw that part up because it would waste so much time and money. We can take it down to like 30 minutes, 40 minutes of cure time, and then it's done and you can move it on. But it's also repeatable and predictable. It's not subject to the weather. It's not subject to the shop. It's not subject to the coating. Like, we know we can get the coating cured this quickly every single time. So it helps them batch their production better. It keeps less work in progress. So we see a lot of work in progress prior to this too, because I have to wait till tomorrow before I can touch this again. I got to start working on something else. So you bring something else in, then you bring something else in. You got all these jobs that are in process in your finished shop, all of which have the possibility of getting beat up or damaged, because the longer you stay in there and accessible to everybody, the longer stuff happens in shops. Carts get hit, people hit things, and stuff gets dropped. And so it lets them shrink their work in progress and also get jobs through much more efficiently.
So does it change the cure time depending on how many parts you put in the shoebox at a time? Like, how is it, and are you able to measure something like, okay, or is it just opening up and seeing did the time work and it's fully cured?
Yeah. So the way we do it is when we install it, we stay there with you for a little bit and actually prove out your times. We've done enough now where we know kind of where to start with these. And this isn't a batch oven, so you don't put it in, set a timer, and wait and pull it out. You're going to be putting some parts in, like you'll be putting some primer in here, and then the next piece of that is you put some top coat in beside it. Or this rack goes in, I'm working on another rack. Okay, that's done. I'm putting that in. Well, the one I just put in is probably done. So I'm putting that in, taking the next one out, moving it on to the next process, bringing the next one in. You're fully walking in and out and using this the whole time. So what we do is we time carts, right? There's a bunch of different ways people time these carts, but you basically are timing per cart, not per batch that goes in the oven, because we're able to be flexible with what goes in, when, and how, because we're running at a low temperature. It's not an oven, it's an industrial heater. And we run it about, depending on where you are, 95 to 105 temperature wise. And so, it gets that hot in a lot of shops in the summer, right? So it's not a dangerous heat, and it's not a harmful space to be in. So You just walk in and out of it. You bring parts in, bring parts out as needed, and you time it per cart.
But then once you know the time for this specific finish and these specific material I'm working on today, every cart you can time the same.
100%. Yeah. We know primers will take this long. We know, seal coats take this long. We know clear top coats take this long. We know our white pigmented colors take this long. We know our dark colors, because all of those factor into how long it takes. They're going to be within a window, but your primers are going to take 15 minutes maybe. And your top coats are going to take that 30, 35. Just depends on what you're doing with it. But yeah, everything on that rack or on that cart will be cured at the same rate consistently. It doesn't matter how full it is, everything's going to cure. And a lot of times we don't even see them get that full, because by the time we get the work to it, the work that's in it's coming out. And so it's not like we're just stacking a ton of stuff in there, because by the time the next piece is ready, because we have doors on both sides, you're pulling something else out. So you're always kind of just, you have this circle that's working with these parts.
And is it possible to overcure something?
Yeah, it is possible to overcure something. In our system, not really, because we don't use a ton of heat. When stuff gets overcured is when it's interacted too much with too much heat, and it becomes brittle. The paint becomes brittle because it's baked. Your surface temperature gets too high. And so in ours, our surface temperature just stays low. Like, we're never going to get up above, at the most we've seen some of them run like at 110, 115. And even that is kind of below the spectrum of hurting your coatings. And this infrared, once it's done penetrating that coating, we can't continue to penetrate it. There's nothing to go in. So it just starts reflecting off the surface. And so really the only way to overcook it is if you get it too high in temperature. So we have parts that stay in there. People forget about them 3, 4, 5 hours. It doesn't matter. It's not going to overcook them or overcure them or hurt the substrate. That's really the bigger thing, is when you're in these ovens for too long with too high heat, you start getting glue joint problems. You start getting some delamination on your veneers. Your edge banding can also delaminate. And that's where you get into real problems. Because when you're baking in a batch, you cycle that temperature up, and then you wait, and then you have to get rid of it, because if you don't, you're going to harm your parts. They're going to get too hot. With this, you don't have that problem. We don't want to cook them with temperature. We want the IR to cure them. Temperature is going to help, and the air movement is going to help, but we're not trying to bake it.
So are there any assumptions or learning curves people have to go through that are coming from a more traditional use oven, right? There are things people are that you have to kind of retrain them. Hey, this works differently, or, what used to be true is no longer true.
Yeah. A lot of it is the biggest thing is getting them to get the parts organized in a way that they shrink their work in progress. The actual implementation, the install, it is very simple to use. And so there's not really an operation learning curve for it. It's about getting your parts in there. And honestly, we've seen very few problems with implementing it in the shops. Once it's turned on, they're moving their parts into a space already to cure. Now, instead of just leaving it here, you actually just roll it into the shoebox and get it cured and then bring it out. So much less on their shop floor while we take up some space with that oven or with the curing room. The amount of actual racks and parts that they have sitting around just waiting to cure dramatically reduces. So you actually take back square footage for other things, because you don't have all these parts just hanging out. Now you're actually getting them through your shop and getting them to the dock door where they can get out and to the customer, as opposed to having one job sitting here and one job sitting there, all at different stages of finish, because you're just waiting. And so this lets you get it all much more contained. And traditional ovens, again, they take longer. You're going to have a longer flash time before you can just bake them. And there's a lot of different types of those, but the most common one is probably a convectional hot air oven. We see those where it's just a room and they pump in hot air. Right? Hey, here's hot air. Let's see if it can cure. And what happens is it helps, but when they bring it out, they still have to let it shrink, because they're really only getting it to where it's dry to the touch, not to a cure. And so we're getting to an actual cure, not just dry to the touch. And so you have less time outside the oven just waiting for it to finish and then get out the door.
Also, with the traditional oven, you mentioned flash time. Typically, are they loading it up, turning it on, letting it, run and then letting it cool down and pulling parts out? Like I imagine there's other logistics involved.
Yeah, it varies. So if you're using like a batch oven, we'll say like an infrared, like what do they call them, like a prime heat type oven, where it's a batch, you bring it in and it has, 60, 70, 120, whatever IR lights that go through a process, right? They slowly warm, they get hotter, and then you eventually get it to the place where you're putting full power on it and it cycles through a batch. That's one way they do it, but you definitely have to have some flash time before that. Another way is like those convection. They don't turn those off and on. The other one's just electric IR, so it turns on and off. The other ones, the room has to stay hot because it's so hard to heat a room with just air. Mm-hmm. And so they just keep it on and keep the room hot and try to just keep it hot. And so you definitely have to flash before you put it in there. Ours, you have to flash too. It's not unique in that point. You don't want to put soaking wet paint in front of an emitter. You're going to run into problems. That's universal across the board. Most coatings need a little bit of time just to relax, just to lay down a little bit before you start curing them. The back end of that is like if you're in a batch oven, like you do one batch at a time, you got to fill that cart up and then you wait. And you just kind of keep stuff in queue. With this, like as soon as that cart's ready and flash, you're just putting it in and you're putting multiple things in, left to right, front to back, you're filling it up. And then you don't have to wait for the batch to be done. You're like, hey, my primer's already done. Let's get it out of here. And there's no separate recipes for it. You just put it all in there.
Awesome. So who is the Shoebox not for? Because I imagine you get a lot of people that come to you, right? Are you ever having to steer people away that are thinking it's something it's not?
The biggest thing that it's not, it will not cure powder coating. So when you're in the metal world, there's a lot of powder coating. And powder is different because it has to get to a very high temperature to cure, like 400 or 500 degrees for a certain amount of time to actually cure and be done. This is not for that. We don't cure powder coating. We don't build these to cure powder coating. We can build them to what's called gel cure, or final cure. Basically hit it with a ton of IR energy at the end or before it bakes. And so it helps speed up that process, but we do not cure powder coating in this type of system. That's a completely different thing. Just because of the amount of heat you have to have and the way you have to control it, it's just a whole different animal. Basically any liquid coating, like there are metal coatings that are not powder coat. If it has a carrier liquid, whether it's a metal, glass, PVC, wood, clearly, we cure styrofoam, we cure all kinds of substrates. It's really about the coating. So we haven't run into a lot of situations where it's like, this isn't for that. You need a different type of oven for this. The vast majority of places we're in, like they're just spraying wet paint. They're not powder coating it. And so if they do, we'll send them somewhere else. We don't really do powder coating.
Awesome. So what are you seeing coming in the future? Obviously, you guys are rolling this out. This is still relatively new technology for the U.S., but what else do you see coming down the pipes for finishing technology?
One of the things, for finishing technology, what I see a lot of, and I know everyone says this, but like robotics is going to be a big piece of that moving forward. It has become hard for these shops to find good finishers. I don't want to call it a dying trade, but it is getting more and more hard to find somebody who's really good at this hand spray wise, because the training time, the lead time on it is extensive. It just takes a long time to be a really good sprayer. There's an art form to it. And a lot of these shops trying to find guys to do it or girls to do it or somebody to do it. But it's tough, right? Like not a lot of people love standing in a booth covered in a mask, getting overspray all over them while they're finishing a part. It's hard to find people to get into that trade. It's a very good paying trade. And if you're really good at it, you'll make great money, but it's hard as the trades. It's hard to get the next generation into it. And so what some companies are doing is like for some of the stuff, we just have to automate. We have to get some robotics. We have to do everything flat and get the curing done. So we don't have a skilled laborer. We have an operator. It's really what I see in a lot of shops that they're trying to get to is more, we need an operator, not like a high cost finishing person, right? Because it's a hard job and you're beholden to them because like if they do a good job, it's very important that it looks great. It just is in this industry. If your finishing is terrible, like you're not going to get a lot more business. And so I see a lot of people moving towards that, or at least exploring it, whether they're actually doing it or not. kind of varies. They're still patching, and there's still some finishers, but like you go into these shops and you look at the finishers, a lot of them are on the older side. They're going to start aging out. They're going to start retiring. And there's not a ton of people that want to jump in there and start spraying in a booth. And so I see automation in that form. They want operators as opposed to high skill, high pay positions.
Yeah. Even in sanding technology, we're seeing it as well, not just the spraying.
Oh, yeah.
Right?
Yeah, absolutely. I would say the sanding part's even worse than the spraying part. Hand sanding these parts it's a hard job.
Yeah.
It's a very hard job. It's very important. That's what's crazy is these two, sanding and finishing, is just such an important part of your process. Like, it doesn't matter if that's the world's best door. If you spray garbage on top of it, it's garbage. It doesn't matter.
Yeah. Awesome. Well, what advice do you have for shop owners or finishing departments out there?
One of the things that I would recommend is try to get an actual hold on what it's costing you. So many times when I have this conversation, it's like, what is your labor in this? What is the cost in this? How much is this cure time? How much is this lag before it gets in there? What is it costing you when all your finishing, all your production just kind of gets choked in this one point? And they don't know. It's like, I don't know. That's just part of the business. And you can see very directly on the other parts of the process, like how fast does this go and how quick and how much labor. Like, it's easier to quantify those things, but finishing has become, or is, in my opinion, in my experience, very hard to quantify what it's actually costing you, time-wise, labor-wise, material-wise. And so being able to get in there with them, hey, let's actually understand what this costs, right? Let's understand your production and understand how it goes through. And some shops do great, but most of them that I'm in, especially on the smaller to mid-size, where the owner is so involved in everything anyway, he's running a million different ways trying to get parts out. He's installing, he's helping on assembly, he's like, and they're small shops. And so it's hard to quantify that. And so much, I think so much money and so much time is left on the table in finishing because it's just hard to understand. Right. And so there's a lot that can be learned if you just take a little bit of time to understand your finishing and really what it's costing to get parts in and out. So yeah, spend some time understanding your finishing process. It's a big part of what we do anyway. Like, we're consultants at that end. We talk about curing and we sell curing stuff. I've been around finishing for so long that a lot of it's just, hey, did you know you can do these things? Did you know about organizing it this way? Did you know you can change these things? And so that's a big piece of what we bring to the table as well. Hey, let's understand this better and let's fix this flow. Like, you're walking on top of yourself multiple times just to get these parts here and there. Let's just flip a couple spaces and make this easier.
Yeah. Awesome. For people that are interested in finding out more about SCHUBOX or elevated finishes, contact you, what's the best way for them to do that?
Yeah. So, I mean, our website, elevatedfinishing.com. We have a YouTube page, Elevated Finishing, on Facebook, Instagram, all those. It's just Elevated Finishing. Look them up. We have videos. We have some explanations. We show a lot of our installs. We have testimonials, case studies, all things that you can see and understand that the companies have taken control of that bottleneck. It's like, hey, this is what they have seen. Now that they've addressed this and they've invested in actually helping their finishing, this is the feedback. Like, we just did one where immediately it doubled their capacity, like overnight. It doubled their capacity. And so that's what we get. Like, the problem then after that is, let's backfill. We need more jobs. Or there's almost, if you have a large job and you implement this, it almost pays for itself just in that job because of the weeks it takes off of the lead time of getting stuff out. So yeah, elevatedfinishing.com and all the associated Elevated Finishing socials is where you can find them all.
Awesome. Well, if you're listening, we'll have those linked in the show notes so you can go down and jump right to those links. Ryan, thank you again for coming on and sharing about Elevated Finishing and SCHUBOX and all the great knowledge you've shared with us, and I look forward to having you on again in the future.
Absolutely, Jacob. We'll see you again soon, man.
Thank you for listening to today's episode. Do you want to stay up to date about industry insights, new content, and our community of millworkers? Go to ductworksmw.com to sign up for our newsletter. I'll see you in the next episode of Verify in Field.